Hello again. Okay, today we are going to talk about quadratics. We're going to take a minute away from linear stuff and look at quadratics, and they are totally different from linear. Okay, so that'll be kind of nice getting a fresh new look at something. Okay, so what we have been looking at is something like this: y equals 2x plus 3. Is that quadratic? I can tell you right now, it is not. Why? A quadratic equation must have an exponent no larger than 2. I don't even have an exponent, okay? It's got to be 2, period. It's got to equal 2, can't be any higher, and it has to be located on x. Do you see that here? No, you do not. Okay, so that is not going to work out for us. So we're done looking at those type of problems for right now. So what you need to know about a quadratic, it has a power of 2. Okay, pretty much that will summarize the textbook definition, okay? And the power is usually located on an x, okay? All right, so it'll look something like this. This is an example of a quadratic equation. I could go even crazier, x squared plus 2x equals y. That's still a quadratic equation. There's one exponent of 2. We are good to go. Okay, so that's all you need to know about that. Okay, so let's start to get into more of the specifics. Since this is an intro, I'm going to give you a little bit of everything today. You're going to want to take some good notes, okay, because we're going to revisit this topic later on in the course. The next thing that I do want to talk about, though, is standard form. Now, you may be saying, hold up a second. We've talked about standard form before, and you're absolutely correct. We have. But we talked about standard form in a linear equation sense. Okay, now we're going to be talking about standard form of a quadratic. Okay, so it looks a little bit different. Okay, so let's look at the specifics. First thing that you see, it looks like this. There's going to be numbers here where all those red things are at. Okay, so it's going to be ax squared plus bx plus c equals y, f of x, or 0. Those are 3 possible ways that you may see it. I can tell you right now, we will be using this one and this one. We will see 0 more commonly used at the end of the semester. Okay, so just keep that in the back of your mind that it sometimes equals 0. And we want it to equal 0 later on in the semester. Okay, let's revisit this. So some of you guys might be like, whoa, I'm used to y, I'm used to x, but this f of x, guess what? We've actually learned it, okay? All it means is f of x means y. They're the same thing, so don't freak out when you see that today, okay, or in your homework. A couple other things about standard form. Standard form has to be in a certain way, right? We've already talked about this with linear equations. Can the a be negative? Sure, we don't care. So that's a little bit different from the linear stuff. But it has to be in decreasing order. What do I mean by that? That the exponents must be going from high to low. Okay, so we have 2, what's the exponent on this one? You got it, it's a 1. So 2, 1, and then there is none. This is just a constant number. This is called decreasing order, and so this is in standard form. Okay, so let's dive in deep into this equation. Let's learn what all these pieces mean. Do we need to have every single one of these pieces? No. What's the only one that we must have every time we do this? It's got to have a power of what? We always have to have this. Can this be gone? Sure. Can the c be gone? Sure. Can both of these be gone and we can still have a quadratic? Absolutely. But if that x squared disappears or it's not on the problem, then what type of a problem is it? Well, it's a linear then. So right now you've got to have that too. You don't need those 2 pieces. But what do those 2 pieces help us to do? Well, this right here, this is our constant. Okay? This is also known as our y-intercept. Remember that. We're going to be graphing that today. So the plain old number where there's no variables located near it, that is our constant, that is our y-intercept. Okay? So where this graph crosses the y-axis is at that number. Okay. I underlined this. We always got to have this. But more specifically, if we know A, that helps us. We're going to find out what type of vertex that we have. So that's what we're going to do right now is this A is going to tell us a lot. Okay, this A is going to tell us where our vertex, is it going to be on the bottom of our graph or at the top? We're going to talk more about that in a minute, but just keep in mind, we are going to use this A for a couple things today. So that's our y-intercept. That tells us a little bit about what our graph is going to look like, okay? Decreasing order, and we're going to be using those two types. Okay, let's move on. Let's talk about what the graph is going to look like. Okay, quadratic looks like this. It opens up, so that if rain came in here, it's like a bowl. And then it opens down. It's like a mountain. Bowl or a mountain. Those are our two options in Algebra 1 right now. Okay? So what we call these U-shape, so it's always a U-shape, there's a specific name for that, and it's called a parabola. Okay, a parabola. Very important. You're going to hear me say that today. How does our quadratic, what's our parabola look like? Does it open up or down? Does that make sense? So this is opening up. This is opening down. So let's go ahead and put that here. Okay, easy enough. Okay. There's a couple other things that we associate with this, okay? So let's go a little bit more in depth at looking at these two shapes. I gotta make some more room here. So let's take a look. All right, we have our two shapes. We have the one that opens up and the one that opens down. I just totally stretched that out. It's okay. All right, the one that opens up. Okay, what did I say before? We wanted to look at that A value. That A value right next to the x squared tells you if it opens up or down. So if the A value is positive, it opens up. Okay, does that make sense? So the number next to x squared tells you if it opens up or down. This one opens up. Look at the down. If the A value is negative, like -2, really don't care about the 2, just that negative. If it's negative, it's going to open down. Okay, so the number next to x squared is very important. All right, there's a couple more things that we need to know about this. Okay, right about here, I'm just going to guesstimate, somewhere right about here. Those are called our vertices. Those are our vertex. One's located here, one's located there. They're right at the tip of the parabola. So it's right at the bottom of this one, and this one's right at the top. What are some other words that you may know in your vocabulary that would mean it can't go any further? It's at the bottom. It can't go any further down. It stops and bounces back up. Well, we call this type of parabola a minimum. Okay, it's a minimum vertex. Okay. What in your vocabulary, or the opposite of minimum, means it goes as far as it can go up high, and it goes right back down. So this is at the what point? You got it. This is the maximum point. So it's a maximum vertex. Does that make sense? Okay, I would draw this into your notebooks, okay? So when A is positive, it opens up, and it's called a minimum. When A is negative, it opens down, and this is called a maximum parabola, or maximum vertex. Okay? Does that make sense to everybody? Hope so. Okay. Well, now that we know that, let's dive into pieces that we're going to need to find. Eventually, we're going to graph these. Okay, the next thing that I wanted to look at is going to be how to find the vertex of these parabolas. Okay,